Hello, everyone. Today we are looking at the memoryless property of exponential distribution. And I think we did this in our lecture 4, so we are going to look at how to prove this property. So the theorem states that the exponential distribution has the memoryless property if for all non-negative integers s and t, probability that x is greater than s plus t, given s greater than t, is equals to probability that s is greater than s. So we are saying that probability of this one is the same as this. So we are going to show this by proving. So if you remember, if you have probability of A given B, that's conditional probability, is the same as probability of A intersection B over probability of B, right? So in this case, probability of so in this case, the probability that x is greater than s plus t, given x greater than t is equals to probability of x greater than s plus t intersection s greater than t, right? All over probability of x greater than t. So let's look at the expression or the numerator part. Let's look at the numerator part. That's probably that x greater than s plus t intersection and probably that s greater than t. This one is the same as what. Let's look at, let's say, okay, let's draw a number line. Let's say you have this number line starting from 0. Is okay, starting from 0, because we said, okay, so let's say start from 1. Let's say starting from 1, 2, and we have a certain s here, right? S, and then we have s plus 1, s plus t, right? This is s plus t. Is okay, great. So if I'm looking at s greater than s plus t, s greater than s plus t will start from this point. This is a point of st, right? So all values from this part represent what? X greater than s plus t. Is okay, great. And let's look at s greater than t. So let's see, and the next one is s greater than t. Okay, so let me draw the number line again to explain it for you to understand. So let me clear this. Okay, so let's say this is our number line, and we have, let's say we are starting from 1. It's okay, and we have the point t, and then we have t plus x is going to be somewhere here, right? This is a point t plus x, this is point t, right? So if you're looking at probability of x greater than s plus t, that means it's going to any value above this area. It's what we called from here. It's what we called we call it x greater than s plus t, right? And if you're looking at the point where s is greater than t, that is also going to be this one, from this point upwards. It's what we call x greater than t, right? So if I'm looking at the intersection between this point, then the intersection between this line and this line starts from only this point, right? Upwards is okay, because it is only the numbers here and here that can be found in the both sides. Numbers below this part, that is below this part here, can only be found in s greater than t. So that means the intersection, that means probability of x greater than s plus t, and then s greater than t is equals to probability that x is greater than s plus t, right? I hope that is okay. Great. So then I can write that probability that x is greater than s plus t, given x greater than t, is equals to probability of x greater than s plus t, all over probability that x is greater than t. I hope it's okay, right? So now, great. So the next one is let's try to get our exponential function. So our exponential function is so that is a PDF. So that's we call it probability density function. And when it's discrete, you call it probability mass function, PMS. So this is the same as integral from this up to lambda e raised by negative lambda x, right? So if I'm looking for, in the case of probability that x is greater than s plus t, is okay. It's same as integrating from s plus t up to infinity lambda e raised by negative lambda x dx, right? So when I want to integrate this, it's the same as when you want to integrate, it's the same as lambda e raised by negative lambda x. You divide by the exponent, which is minus lambda. So this cancels this, right? And then you have it as e raised by negative lambda x minus minus here, right? From from s plus t up to infinity. So when you fix in infinity, that's going to give you 0. You bring your minus. And then when you fix in s plus, you're going to minus e raised by negative lambda s plus t, right? So that means this becomes positive. So you have it as for probability that x is greater than s plus t is equals to what? E raised by negative lambda s plus t. And then when you're looking for the probability of x greater than t, that is also going to give you integrate from t up to infinity lambda e raised by negative lambda x is okay. So when you integrate, you're going to have it as e raised by minus e raised by negative lambda x, but from t up to infinity, and that's also going to give you 0 minus, there's no minus here, e raised by negative lambda t, right? And so that will give you positive of e raised by negative lambda t. Great. And but we know that probability of but we also know from this that we have probability of x greater than s plus t, given xt, given that is equal to what? Probability of x greater than s plus t over probability that x is greater than t, right? Now, so when I fix it, when we look for the top part, we had it as e raised by negative lambda s plus t, and then we had the down part to be e raised by negative lambda s, right? So that means this expression is the same as e raised by negative lambda s minus lambda t is okay. So this is t here. This one is t. This is t. Great. Minus. So this is minus. When it crosses this up, becomes plus lambda t, right? So that means this expression cancels this expression. So you have it as equals to e raised to the power negative lambda s, and this expression is same as what? So you have it e raised by negative lambda s, and this expression is same as probability that x is greater than s. That means you have proved, right? This is quite easily done. Thank you.